But tonight we have 4 demos, and we're excited to hear from our speakers. And up first is Elliot, the co-founder of Chalk.ai. All right. You better now.
Thanks, Wayne.
There we go.
All right, well, I'm gonna tell you about Chalk. We are a query planner for computing feature values in real time. So this is really useful in applications like fraud, where you're trying to spot if a debit card transaction should go through or not. We're processing about 1/3 of the world's debit card transactions. It's really useful in things like e-commerce, where you're trying to make recommendations in real time as people like tap a screen or say yes or no to some content that you show them, like with Whatnot or Turo or Apartment List, where we do kind of more of the like traditional Rexis use case. And I guess what's really different about us is that we really care about what you can run like in the moment. And so what does that mean? I think a lot of people, when they talk about real time, they really think about streaming. But really streaming, I would say, is kind of more like near real time. It's like whatever you put on that topic, and then it went around in a little loop and ended up in some kind of transactional database for you to read from. But it's not actually like going to the source of your data or like running a function in the moment. And so what we do is we figure out how to run your Python UDFs, your SQL queries against the databases where the data actually lives, and your things like aggregations in forms of expressions, and also things like LLM calls, and then execute it at the moment you need the data, like just in time. So I'm going to show you a quick demo of kind of what that looks like. So we're going to lay out a little bit of a schema for our data. So we've got users in this example application. It's kind of like a fintech use case where we'll have credit reports and transactions and users. And they've got some simple scalars like IDs, emails, names that we're going to pull from a Postgres database. But they've also got some stuff we'll compute via Python functions, like what's the email username for this particular user, or were they deny listed? These are all going to be features, so we can request them to go like feed into an ML model. And some of those features are really particular, and they describe things like joins. So for example, I'll say that my user has a credit report ID feature, which kind of maps to the primary key on another one of these classes. So kind of like something like a Spark, you can write these types of expressions like, oh, count up the trade lines that I've got, or sum the balances over the trade lines. There's also kind of built-in functions that are accelerated, like, oh, I want to know like the Levenshtein distance between the user's name and the memo, for example. So that's a little bit of kind of like laying out the data schema itself, but then we can go connect it to real-time sources of data, whether that's Python UDFs or SQL. In the case of SQL, what we can do is just write a SQL query. So in this example here, I'm going to connect to my Postgres database where I'll pull down a bunch of transactions. And so this is just a plain SQL file with these 2 special comments. And this first one is saying that I resolve part of the class transaction. So what does this mean? It means that the columns here, like ID, amount, user ID, @ memo, are going to also appear over here. And when we need to go get data about transactions, we'll actually run this query instead of like some ETL process that's going to bring it into a feature store that's high performance and conserve this. We'll also do things like push down filters and projections and some aggregations. So you're not going to be like rewriting this query for every like use case you have. If you need to pull transactions for a user, we'll push down a filter that just gets them for the user. If you want just one of a specific ID, we'll push down a filter kind of like that. So that's the SQL side. But you can also integrate this really nicely with Python UDFs. So for example, if I wanted to write a function that I could like either backfill or run in the moment, I could put this little decorator on here online on just any old Python function. And the annotations are going to be a little specific here. So for example, I'll say that this function get email username, which is going to try to pull out like the part before the @ sign, takes in a string, but like a really specific string. It takes in the user's email. And it outputs like also a string, but again, like a really specific one, which is what's the email username. And the mechanism for doing that is just this Python function. So I'll like take the email and like split it at the @ sign and take the part before the @, and then I'll check if Gmail's in it because they've got some funny things where you can like put a plus and then have a million aliases. And I'll just return the lowercase as kind of like the canonicalized version of this. Downstream of this, I could write another function which like checked if that email username was in a deny list or something like that. So I've got this email and deny list function. Maybe I want to change it to say, also take in like the username, and I'll say that either the email's in the deny list or the username's in the deny list. And so now we can go query for some of this data, and all of this orchestration will kind of happen automatically for us. So if I go run a query for a specific user, I'll get back all of the features that we know about them. We can also request more data back. So if I wanted both the user and maybe like the transactions for the user, I could pull down all of that information and we'd get like a lot more data. But the idea is we could just determine at runtime what we need to query plan, which kind of takes us to a query plan. So what is that? Well, if you've ever run like Postgres explain analyze or looked at like the Snowflake query plan viewer, that's what we're doing here too. We've got things in here like joins and filters and projects. And we're orchestrating all of these functions to figure out like what needs to run by way of hitting SQL, what needs to run as a Python function, also like what expressions need to run. We really care about latency, and we do a lot of things to make your code run faster. One of the really cool things that I wanted to show you is just that we'll be able to turn Python functions, like large class of Python functions, into expressions. So for example, we were looking a minute ago at this get email username Python function here. And actually what ran for us was this expression. It was this thing that said, well, we need a lowercase whatever the result is, which is an if then else of checking if Gmail's in the string or not. And if it is, then we need to split the string at the @, take the first bit, and like replace some of it, the portion of dots, and else we're going to do something else. So this ends up turning into, we parse the Python AST and turn it into an expression so that we can run all of it in C++. And what's really cool about this is it's just like a totally unfair advantage against running in like the Python GIL. Like if you want to backfill this over 10 million or 10 billion or even 10 trillion users, we can do this in just C++ in a really distributed way, where with Python you get really stuck behind the GIL. So we really care about the performance of all these things. The other piece where we were able to kind of make some unfair gains is that in all of these SQL connections, like these SQL files we're writing, we're using the native database drivers. So in this case, we're using like libpq to go talk to Postgres. And for Redis, we end up using a Rust library that works really well. So that's a little on the performance side. On the developer experience side, it's also really easy to deploy this stuff and try it out, both in the past and right now. So for example, we just wrote an update to this function here to check if an email was in a deny list. And we can deploy this software to what we call a branch. So what this is going to do is package our software up, put it on a Kubernetes cluster in a way that's very scalable, but not kind of impact our production deployment. So when I go query for my user this time against my branch, we'll be able to see in the web that we had the new data coming into our function in order to compute the deny listed feature. So when this query returns for us, we'll go click on the query plan link here. And if we look where we're running the email in deny list function, we can go check out the inputs. And we can see this time it's taking in both the email as well as that email username. So this lets you experiment with things and try stuff out really quickly and see kind of what's working and what's not, and iterate on that. You can also do this for brand new features. So for example, if I wanted to make like a fraud score, I could take in the data that I want to have. So maybe whether or not someone was deny listed, for example, and their like match score, or anything through the user. So if I wanted to kind of like access data by jumping through the feature relationships that I've set up, I can go make this Boolean feature here and write out my new function and deploy this to my branch and then query for the data. And this time we'll see our fraud score function run, which kind of wasn't in the graph at all before. We've got 18 seconds. We're going to make it. So here's our is fraud coming back for Nicole Mann. She's out. We're not lending to her. Well, that's my time. Thank you all so much.
Awesome. We'll take about 3 minutes of questions. Any questions? Yeah. Yeah.
I'm curious how it seemed like the Python types, which in my head don't affect the runtime, seemed like they were pretty important in determining what happened, what Chalk does. Oh, for the screen. It seemed like the Python types, which I guess in my head don't affect the runtime, seem to affect pretty heavily what Chalk does. What I don't know. What are your thoughts about this?
Yeah, no, you're totally right. I think a lot of pipeline-based things that you look at, like a Spark or a Dagster or something like that, you're orchestrating functions. And you're usually orchestrating functions pretty explicitly, although some of them you'll kind of stitch them together at the end. We're really thinking more about well, how do I just orchestrate my data? And if I just thought about how can I take in 2 pieces of data and produce a new piece without thinking about how it fits into the whole pipeline, it's a little easier to kind of compartmentalize there. I think the other thing that can be really nice about that is that you don't have to make a new pipeline for each model you run. I ran this query which produced a bunch of data, but maybe I just want to run a query for, I don't know, whether or not the user was deny listed and nothing else. If I go look at the query plan that gets run for that, we're actually just going to see something really simple where we go to the database and then we run a Python function. So if you can express your dependencies in terms of data instead of in terms of functions, it's really easy to have composability of these things and even query from different roots. So if I wanted to query from a the perspective of a transaction, I could get just the data about the transaction, or I could say, give me the user as well as the transaction. And then I would get both of those objects, but kind of composing all these functions in a different way because I'm accessing from a different entry point.
Awesome. Any more questions?
Cool use of types.
Oh, thanks. We really like types.
Cool. Hey, Tom, one more, last one.
Sure. Okay. So a thing you could do with a DAG is say, hey, I invalidated one of these pieces of data. Do you do any of that kind of push kind of signaling with these things too? Yeah. I guess that's another thing in my mind real time can mean instead of just fast, which is actually, it was also pretty cool.
Yeah, absolutely. And I think where we end up seeing that a lot is actually on the recompute side. So if I just made this new feature on my user that's talking about the fraud score, I could ask about recomputing that user.isFraud for each transaction, and I could choose to sample some of the data and rerun some of it. So if your data in your tables is already well timestamped, you could just recompute all of it. If you return what we call a feature time column, but you just say oh, this is the canonical timestamp for this particular function or for this data source. You could also say, you know what, I only want to invalidate some of it. I want to recompute the transaction.user.isFraud, but the rest of it, I just want to sample historically and say what were the values the last time we ran this? And then this will just give you a table back of that data at the end to say here's what it would have been. And because these, there's no reason we couldn't have been running get user is fraud in the past, so long as these things were also temporally consistent. So we'll go kind of run the sampling and then rerun your function.
Awesome. Thanks, Elliot.
Yeah, thank you.
All right, cool. All right. Great. Up next, we have Gabriel, who's going to talk about building a